A proper database design ensures accurate and efficient storage and retrieval of data. When we develop an application, we need to retrieve data most of the time, and also we need to have consistency in our data. So if we do not design database properly, then sometimes we can retrieve inaccurate data, or sometimes it can take some additional time to retrieve that data. Okay, another thing is scalability or adaptability in the future. Poorly designed database will make it difficult to add new features or incorporating new requirement. We know that in software development, when a software is developed, it is not done. In maintenance phase, we can add new features or we can adjust new requirement into the software, which is very normal in software development. And we have to keep that in mind when it is designing our database. Those are the few ideas why efficient and proper database design is crucial. Those are the key things. Now let's understand what are the steps in designing database for a new feature or for a new product. So for our better understanding, I'm considering an example feature, which is we want to develop an application which will show all the available discount campaign of different type of stores. For both online and offline store, we will be showing the available campaign on those stores. The store can be of different types like cloth store, furniture store, grocery store, and many more. Sometimes cloth store provide 30 or let's say 50% discount for a certain month or for a certain time period. In our application, we'll show all the stores which have the ongoing discount and also ordered by the offer. Like if the offer is very weak, like they're providing 50% discount for all product, then it will be in the first row, and then ordered by the quality and quantity, let's say, of the discount. So this is a very simple feature. We want to design the database for this feature. So the first step is understanding the requirement clearly. This is the most important part, because based on this we'll approach the following step. So once we have understand the requirement of our application, which is showing the ongoing discount for different type of stores, our goal here is to initially have the tables related to this feature and start working with this feature. Let's say creating a entity for our application. But first of all, we have to discover the entities for this requirement. So one way to find the entities are looking for the nouns in the main feature. So main feature is showing discount. So what are the noun in this feature? The noun are stores and then discounts. So store provides discount. So this is the feature, and the entities are stores and discounts. So we have to find the relationship between the nouns, like stores provide discounts. So one store can provide multiple discount, like 50% discount for this and 30% discount for that. Okay. So the relationship here is one to many. If you're not familiar with entity relationship, then there are 4 types of relationship in database entities, which is one to one, one to many, and one to many in reverse is many to one, and many to many, which is a composite relationship. So here in our feature from store to discount, we have one to many relationship. So for discount to store, the relationship will be many to one. Okay. So for our better understanding, let's have a example year diagram, which is store and other one is discount. Okay. So the relationship between them is one to many. This line identify one to many relationship between these two entities, And so we have discovered our entity relationship, which is a technique for designing database. So we have discovered our main entities and their relationship for this feature. And each entity will have their own attribute like ID, name of the store type, store category, location, website URL, and many more. And also for discount, we can have a relationship between store and discount. So once we have discovered our entities and the relationship, the next step is the normalization. What is normalization in database if you're not already known? Normalization is used to minimize the redundancy from a relation or set of relations. Normalization have different type of forms like first normal form, second normal form, third normal form, and many more. So we have to make our database compliant to normalization form. I think for this up to third normal form is more than okay. The first normal form is to have a unique identifier for each entity, like having a primary key called ID. Same goes for discount. We'll have a primary key called ID, and all the other value will be accessible uniquely by that ID. The second normal form is the relationship between store. So let's say a store called Arong is providing some discount. So we cannot directly have the name of the store here, like store name. That will not make our database consistent. Instead, we want to have a ID. First, we want to have an entry in our store, and then have the reference of that store as store ID in our discount table. Okay. And the third normal form is if we want to have some additional information about discount, we can have that in another table called discount images and refer this discount ID in that table. And discount images will have the URL for images, disk path, name, file type, and many more. So our normalization is done here. The relationship between store and discount is added in the discount table with store ID, and this is foreign key constraint. Now we have normalized our table for this feature. So in this step, we can translate this year diagram to a physical database schema. So for that, we have to identify all the columns for each table. For store table, we want to have the columns as store ID or ID as primary key, which will be auto incremented. The name of the store, which will be worker 100, and store type will be enum. Let's say if the store is online, then the value will be the online. If the store is offline, then offline, then the value of store type will be offline. So we can have some additional attribute like store category, location, website, etc. And for discount, we want to have ID as our primary key. Store ID is the foreign key constraint, which comes from store and is also unique. And then we can have our discount type, like if the discount is percentage or a fixed amount or a gift. We can have a column for discount value, and then we can have the start date, end date, and a sort order if we want to sort these discounts in some way. Okay, these are the attribute we want to have. So once we have discovered the attribute and their type, we can create physical tables to execute according to our database. We can, in this step, we can take help of ChatGPT. Like in a ChatGPT prompt, I want to say that I want to have a table called store, and these are the columns and their types for the table. Give me the data definition language for my Postgres database or for my MySQL database. Okay, then ChatGPT will provide you something like this, right? So once we have our tables, the design schema, then we can start our work. But in this case, we can check for some additional thing, like if the primary key and foreign key is correctly added, and if we want to have some additional constraints like uniqueness, not null, and then we can consider some performance thing like indexing. Those steps can also be done in the later step, but we should consider those things when we're designing our database too. Like sometimes when we're working on a feature, then we can discover that denormalizing few tables to a single table would be a good idea. In that case, denormalization would be better. Okay, so once we have considered all those things, we can start working on our application features. Like we can create a Java entity if we are working on Spring, and then implement our features. So this is the steps to properly design database for any feature or for a application from scratch, which is understanding the requirement clearly, modeling the entity relationship, normalization, and then schema design, and then the additional data integrity and constant check, and also the performance considerations. So I hope you got the idea how to design relational database properly. If you have any question or ideas, you can write down your comment below. I'll be happy to look into your comments, and in the next tutorial I'll show up with other important thing a new software developer should learn. So until next time, happy coding.